Hi everyone. I hope you're enjoying DevConf on the third day. I hope you're not too tired for this talk. It's going to be a talk about features that people might not know about Podman. If you know, it means that you are a good user of Podman, like you use it intensively, because I think that you might not know some of them. I didn't know some of them. I knew a little bit of, like the first one I knew. We'll see how it goes. And I learned quite a lot of playing around it. I'll have live demos that I will, I'm afraid of the connection, so I will actually play some recording, but all the demos you can play, you can run it yourself. They'll be in the presentation that's linked at the end. So, my name is Nicola. I go as Inknos on GitHub, and I am part of the Container Tools team, and I maintain PodmanPy, which is the Python bindings of Podman. What is Podman? You might know about it. By now, we also have a booth. We had many talks. And if you're here, you probably know or want to know. So what is Podman? Is a fast and light container tool to run containers, build containers, do a lot of things with containers. You can interoperate very well with many systems. It is secure. It doesn't require root with other container tools do. So you don't have as many privilege escalations problem if things get out of your container. It's open. It's fully open. Even our desktop GUI, it's open. So it's in the spirit of free and open source software, of course. And it's, as I said, very compatible. It has 2 layers of API that can interoperate with our libpod layer and with the Docker layer as well. So we can talk with different things. And I should put $1 in the buck because I said the word. But yeah. So next, why should you use Podman? Well, as I said, it's daemonless. So if you want, it doesn't require to have systemd there. You can run it in Alpine if you need. You will lose some features that will require, for example, systemd timers. But that's OK. It can run containers there, and it doesn't need to have a daemon running. Again, fully free and open source. You can go to the code. You can see what's doing. And you can ask for features or implement those yourself. We had a workshop about it. And we are giving away also plushes to the one that contribute to our code base, or even the documentation. And then I'll show you why, for other reasons, it's also awesome. So the first thing that I believe it's really cool feature about Podman, and how many people actually don't know much about Podman, raise the hand. Like you use it sometimes, you copy paste scripts, OK. So you might be a command line user, for example. So command line users is where we have like a lot of fans of Podman from, and it has a great autocompletion feature. And you will say, of course, autocompletion is something that every tool in command line has, but sure, in Podman it works a little different, because the autocompletion in Podman actually is built, it's basically the way it works is that every Podman binary gets what it needs to autocomplete, and on the fly generates the autocompletion bash, ZSH, fish, PowerShell even, scripts that then are read by your shell. So the way it works, for example, you have a container, you do inspect, and you do format to get just some parameters of inspect. Inspect gives you all the information of a container. So you want the name, the ID of a container, which command is running on startup, for example, and you might need to use format to understand. And format has sometimes an itchy syntax for the ones that are not familiar with JSONs or stuff like that, but it can autocomplete that, and I'll show you in a second. Also, Podman can talk with different systems where Podman is installed, and the way it does is through a connection. Let's say you have a host with an SSH Podman running there, and you can SSH into that, and you have Podman running there. You can, of course, run commands there through connection, and that can also be auto-completed. So you can, Podman, what does it do? Fetches the information from the system, and it can autocomplete on the fly. And it also works with your binary. So if you build a tool, if you build Podman yourself, it will, and you add a feature in the autocompletion, it will work. I'll show you now. Demo time, ready to have things that break. So what I will do, again, I'm afraid about the connection, so I'll show with some Askinema script. So actually, no, this one we can run it ourselves. So let's see. So we have Podman sorry, I have shaky hands. I'm a bit excited, so I'm typing bad. So Podman PS, we have some containers running there, all right? So let's say that if you can't read, if you know what this is, these are all my running containers right now. So there's one that is called Alpine, and it pulled Alpine. So for example, I want to do Podman, inspect, Alpine, okay? All of this is really easy to do. You have a really, really long output of everything that is about that container. So we just want few things, and we want to get to the syntax of format. So what we do is that we have to specify the attributes here. So we just tab here, and we get the auto-completed arguments. It's convenient. We can do, like, for example, ID, it's completed, and we get the ID of the container. Or else, I want to see which command is that running. I know that it's running top, or I believe it's running top. And where is the command, the CMD? So it's not showed here, but there are some fields that end with dot, not with the double bracket. So it might be in one of those fields. So let's see. So it's in, I know where it is, so it's in config. And I tab again, and the first demo didn't work. Round of applause for the first demo that didn't work, because this runs into the browser. So like Podman, inspect, on the terminal, of course it works. Format, oh, I didn't specify the container, Alpine, config, and CMD. And there we have it, and it runs top. So we actually know what the container does. If you want to be sure, you can actually see the logs of Alpine, and they're stopped running there. Okay, cool. I said that I can also autocomplete containers that are far away in some system, and how does that work? So the way it works, I'm not going to change to the slides just yet, so I'm sure of what I'm doing, is to check the system and connections that Podmans provide. So I have one remote host that I set up here. I know that's running a socket in the user space, so it's in the run user, like the 1000, so the default user. And so let's say that I want to fetch some information of containers that I have there. So connection, that's the name that I gave. And let's see that I want to do inspect on a container that is, it's called DevConf something. So I do like devc and tab, DevConf remote. That's running on the remote host. And then again, like I can do format and ID again, or maybe name. It's not called name. Yeah, it's this one. So name. And there it is, DevConf remote. So it auto-completes even on remote. And it's, I think, pretty cool for when you don't want to parse everything into less or grab the results of Podman inspect. So another thing, Podman auto-update. Who knows already about this feature? Hands up. Not many. OK, good. So Podman auto-update, what does it do? Of course, it auto-updates containers. For this feature, you don't just need any container, but you need a container that's managed via systemd. And the way it works is systemd will have a label, or rather than a label, an entry in the systemd file that will tell that that container needs to be checked if you run Podman auto-update. Actually, to do this, we might need to, well, I spoiled one of the features, but we need to know what Quadlets are. You should be familiar with them. If not, I can show you at the end, because like I have it shown, but I want to be faster with this. So basically, Quadlet is a way to write the configuration of a container in a declarative way. So you have kind of a unit file, like systemd file, and write stuff like you have a container field instead of unit field. And then you have container name, image, published ports, and that will tell the systemd, when you do daemon reload, it will call a binary which will generate systemd unit files. We can see that, but maybe at the end of the presentation, because there are some files to check, so it can take a little bit of time. So auto-update will check for all the containers that have some flag, which is can be, yes, auto-update, registry, or local, or it can be a label in the container, which is IO containers auto-update, and that will tell, for example, a Kubernetes cluster to auto-update all the containers in the cluster with the registry and local policy, or slash some container ID and a specific policy for a container, right? So what it does is, and I'm going to show it in a minute, it will try to check inside a registry if there is an updated image, pull it, and spin it again. So that's why we need systemd, because systemd knows how to spin it back up. And you can't, like you might know with some running container, but you don't know all the details. All right. Another neat thing, also using systemd, is that you can roll back on auto updates when they fail. So that's kind of a feature that you could get with OpenShift, for example, but if you don't want to run a whole, like the whole OpenShift, you can just do it with containers. How does it work? Podman auto update rollback, that's true by default, but I put it there just because it's like, so you'll know. Again, systemd unit, and the containers needs to be run either with SD notified container, this Kubernetes label, or notified true. What this does is that if you have a container that has systemd in there, so some special images have it like UBI, they can call SD notify and tell the container and tell outside to the host that, yeah, I'm fine, let's say. Like I'm pinging back that the auto update was successful. Let's put it that way so it's simple. Let's check it out, this time for real, not like before where I had to go to the terminal, but anyway. For this demo, what are we going to do? We're going to run, all right, stop. So we're going to create 3 containers. The first 2 containers will be generated by a Quadlet. So again, we're going quick, so just trust what I'm doing. They are just normal containers, and one will have the local policy of auto update, the other will have the registry. The third one will just be a container that runs stop, so I call it just stop. And it will have no policy, so we won't ever see it in the auto update scripts. So what happens is that like you pull the container, this is pre-recorded of course, because like connection, whatever. And what happens is blah, 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 you go forward. And what we want to do here is that we need to fake a registry with an updated image. So basically, I am creating a local registry with just running some registry. It's actually here, this line. It just tells run an image that's called registry, expose it on port 1337, and so then I can do push to that registry and trigger out updates from that point. It's quite intuitive, let's say, but maybe if it's not, ask questions or wait for the end. Like we'll go through it if you have more things to understand. So now I'm getting Alpine from Quay, then I'm pushing it to the local registry here. Then I am deleting the Alpine image locally, so I'm sure that's not the image from the Quay registry. And then I am pulling it again, but this time from the local registry. So I know that I have an image that is pulled from that registry, and I will update it. So let's go forward again, and we create 2 Quadlets. The Quadlets like this: container, image, exec top, and auto update registry or local. Fairly easy. Let's say that this works. And the way it is, you generate it with systemctl user demo reload and start it as a systemd unit. And once you run ps, there you have it. You will have the first one is the registry. It's there, holds my images. The just stop. The systemd auto update local is the one that systemd generated, and it will auto update once I rebuild. And the registry, it will auto update once I push it to the registry. So when you run the auto update, you can run a dry run to see which ones need to be updated. And they don't, because false falls on their updated policy. And if I run the command, so auto update without verify, because they need to fetch from some not TLS verified registry, it will just check it out and see that they have a local and registry auto update policy, and updated state is false. They're not. But what can we do? We can rebuild. We can add one layer that just does hello world. And then when we run again the auto update, it's here, we can run it. And one of them, the one with the local, it's pending. So it will run the auto update once I do it. So I just do it, What happens? One is true as updated. And if you check the tags and if you run through the demo again, you will see that the tags and actually the ID of the containers are the ones of the new images. Right. So let's take this image, push it to the registry, and see if the one with the registry instruction auto-updates. So here you just push it, Podman push to the registry. And what it does is that now we will have the registry one, so the first line, this one, will be actually pending. So easy peasy, now you run auto-update again, and you will have, let's go to the end. You will have true as the first image that was updated. So that's about the auto-update feature. But now let's try to see very quickly how does it work for a rollback. Again, I will do the same exact things, but this time I will just do for local update, because I don't need to write a registry. So this is very important. We need to run systemd notify ready in some script that I called runtime, and then once I spawn the container, I have to just tell the command will be, run me. So that's the only important part, is the line that says systemd notify ready. The latter you will find it, I put a reference of the article that explains this in more detail at the end of the presentation in the references. That's the important part. So one container will say, I'm ready to systemd, and then we will update it, and we will remove this line, so the container won't say anymore, I'm ready. So it will be unhealthy for us, or like the update will be not successful, right? So now we build a container. This is like just building from UBI, as I said, we need some image that has systemd inside. And we can go, let's say, forward, it takes a little bit. And then it will be, yes, this is our container file that Quadlets will handle. Again, auto-update local and notify true, very important. Because notify true is what gets, whoa, stop. It what gets the, what reads the information from systemd. We run it, it's there, systemd auto-update healthy, it's waiting for us. And now we build again the same image, and so the local policy, since it finds a local image that's more recent, will try to update to this. But this time, it doesn't have systemd there, so it should fail. Let's see if it fails. Okay, so these are our two images. One, it's tagged as none, none, because it's the old image. The rebuilt one has already the repository end tag. And it will try to go from the one that's marked as D2 to the one that's marked as 2C. That's for when you will try to go through the demo again to see exactly where the IDs change. So the auto-update in a dry run is pending. Now it's trying to auto-update, and we will see that it did a rolled back. It's right here. So the image rolled back, and now the tags are swapped again, because the image that we are running and the image that it's sane, sorry, it's not the, it's like you will see that the tag swapped because the update was, of course, unsuccessful. So I think it's pretty useful. If you didn't go through this again, like I'll tell you at the end, there's the link to the presentations, and the demos are in a nice script that you can run on your machine. If you have a nice connection, you won't have to just run the recording as I am right now. All right. Moving forward. Did you like this feature? OK, let's go. Podman health check. Do you know what the health checks are in Podman? Well, they're common. They are a feature that is defined in Podman at runtime. You can also define it at the build time, but it's a little different, and I will go into that detail at the end. Podman health checks are used during Podman run. When you run a container, you can define and specify health check options. During update, so when you update a running container, as I said, it's not for libpod, it's not a feature of the OCI image, so you can update a running container anytime with health check options. And of course, we have the health check command that will test and run the health check, right? So pretty simple. A health check for your container could be, for example, if you're running a database container, it could be, what's it called, like PG ready or something for some Postgres database that will check that the database is correctly initialized, something like it. So you might run it, and you might decide to run it every seconds, every some minutes, or something, and you have plenty of options to pass to Podman run. All of these you can pass them to Podman run. So command to define the command, interval is every, like the interval, of course, of the health check run. And then there are some nice new features, like where do you store the logs of your health checks? So you can actually now set it and tell where the logs go. And I'm sure that you can imagine that you can set it to some local storage, but it can also integrate with the system logger now, which is a recent feature. Also, you can specify if you have some local destination, what's your max log count, if you want some number of line or size, or health check retries before you define what to do with the unhealthy container. It can be killed, it can be stopped, it can be whatever. You can define what's done. So many more. These same options will apply for Podman run and Podman update, meaning that if you have a container that takes a little bit to run at the first time, you don't need it to rerun it. You can just update it with a different health check, for example, for debugging purposes, and that's fine. So auto-update supports the same flags of Podman run. And then before showing things, I'd like to also say a few words about what exactly Podman health check does, because for some people it's confusing. So you have a container that has a health check that will do like, I don't know, like I have an example, my container will do hello world, right? Health check, it will be always healthy, very healthy container. But it won't show, and some people are like, why doesn't it show? Because it's for scripting mostly, you just need the error code, and then the actual output of the health check, you store it and you see it in a log. So health check has only one option, run. Let's see. So here again, let's play the health check demo. Okay, first of all, we want to run two containers, one with a health command and one without a health command. Okay, very easy. One will be healthy alpine, the other will be alpine. Okay, so they run, and when we do PS, first of all, we see that one is healthy because the health check has been run, and so we know already that it is healthy. Good to know. Then what do we want to do? We want to see where the logs live. So by default, the logs live in this remote location, run user, etc., and then the ID of the container, and then the health checks. And they're stored in a JSON format. So this is good to know. Every time a new health check is performed, you don't just append something to that. This gets parsed, and a new health check is logged as part of JSON. Reasons, it was done this way. If we have different feature requests, we might do differently. It works for this use case, but it's not like a normal append to the file. So what do we do now? As I said, if you run the health check directly, health check run on Alpine, it will say error. It doesn't have an health check, so why are you trying to do it? But if you do it on a healthy Alpine, it will do nothing. Error code 0, actually. And you catch the logs again, and you will have another entry. But let's try to run it like many times. I'll run it like 10 times here, and I see that the default is just store it 5 times. So again, new options, you can increment this because maybe you had a failure on the minus 100th time. So you want to see what's happening, okay? So that's also fine with health checks too. So let's see. We can specify a different directory. Like here, I'm running a new container. It's called Healthy Alpine II. And his log count is 3, and the log lives in the current directory here, right? I can just say dot, and that's the current directory. So we run it a bunch of times, and it will store just 3 logs in the current directory. Here, I just did cat, and this is how the health checks is stored. ID, health check, log. Very simple, very, very simple. And now, the successor of the dynasty of the Alpine health check. Here comes health check the third. Where's that? Oh yeah, no, here I wanted to show you very quickly that you can see where the logs are, again, with the inspect and format. You can find it conveniently with autocompletion. We saw that. Right. Let's do the third one. We want to store this in the event logger. We want to get the health checks, not in a file, but in the event logger, so with journal control, right? So it's easy, you just do log destination, events logger. Then you run the container. Of course, you can update it or run it. It doesn't make any difference. And here is it. Healthy Alpine the third said, hello, DevConf. So that's healthy. And then what's next? Now I can probably go on with showing that you want to update it. So here I'm just updating the first one with a different log destination. Here I'm showing it. We don't have to go through this, but like Healthy Alpine is here and it logged correctly. And the last thing, as I said, you can also define Healthchecks as build time, but that's not our feature. This way, you will build not an OCI image, but a Docker image. This doesn't count for the bugs. So we get a warning. The health check is not supported for OCI. But now if you run this image, you will also see that this is stored in, let's go a bit forward. I wanted to show, this inspection. If you do inspect this image, which is the one that we build with the health check in the build process, it has the health check in the image. So another image, Alpine, it has nil, because sure, it's not part of the OCI. But if you run a container with this image, it will have, of course, the format of config health check once you inspect the running container. Okay, it's a bit convoluted, but I hope you get it. It's compatible with our implementation, of course. And right, lastly, you can, of course, do Podman PS and filter by healthy and unhealthy and get just what you need. All right, so not much time. I'll go very quickly through the integrations. If you didn't know about it, Podman integrates super good with Cockpit and Ansible. If you don't use it, there are more integrations that we can talk about, but like Cockpit, it's great. If you use Cockpit, it just runs really well. You have your containers here. You can run, stop them. When you create one, you will have the options to make health checks that we just talked about. It's great. So like, if you don't use Cockpit, it's a really nice GUI, and it's in Fedora. Of course, you can also run Podman Desktop. It's also really nice, and it can do many things more. And then if you never used it, also for deploying Quadlets, it's really great to use Ansible because it can generate Quadlets really well. So you don't have to care about the Quadlets syntax. So it's like, I don't want to run this. You can define a playbook and run the containers, but I don't have much time. But if you go through the presentation, and like there's a recording of the Ansible integration here, and you will see how it works. So I want to go briefly to other cool features. This has been talked about in another talk that you can watch in the recording by Matt from our team. You can get a compose, and if you don't want to use that syntax or run the compose whale, some YAML file, you can actually convert it and run it conveniently in a kubeplay. And the way it works, it's really simple, and I'll go through that, and then I'll wrap it up for questions, or maybe something more if you don't have. But let's do the compose demo, because I think it's nice. So skinml play, cast compose. So what do we have? We have a compose file, this one, that will define two containers, a volume, some environment variables, and some open ports. This is some, these two containers communicate, and the way you do that, for example, is to do some Podman compose, which will call, in my case, since I have it installed, the Docker compose, it will pull. Now it formats bad, but it's actually a bit better. So let's just go to the end of it, because it doesn't auto-update on the screen. And when it's done, what it does is you will have the Fedora, the Alpine here, the ports are forwarded the good way, the volumes are there, and so what do you do now? If you don't want to use that anymore, but you want to use kube, you just do Podman kube generate, you put there an output file that you want to have your generated YAML go into, the containers or everything that needs to go into that file and be part of your, well, what was the compose and what will be the pod. And then once you have it, of course you can stop everything. This is how the YAML will look. It's a valid YAML that goes with it will create a pod actually. And then, yeah, now I'm just pulling down the compose because I don't need it anymore. And let's go forward to when it finishes. Well, I should have do some forcing here. Yeah, nothing's running anymore. And I do Podman cube play and the YAML, and it will spin up not just the containers, but the pod as well. And the ports and volumes will be all there for you. So you can also put it down. It's easy to manage. And I think if there are some questions, you can reach out here as well. But now we have, how much time do we have now? 5 minutes for questions if you have, or want to see the Quadlets, whatever.
So the Podman compose, what does it do with the command? You mentioned something about the compose.
Yep.
I know that there used to be the Podman-compose project.
Yeah, so Podman Compose, if you talk about Podman-Compose, okay, what does Podman Compose do when you run Podman Compose? Yeah, so you could do Podman Compose, Podman-Compose, they do different things. Podman-Compose was a Python implementation that came from community, and we didn't give direct support to that. It worked, but until like community effort, the maintainer, I don't know who maintained it, but like it wasn't our thing. What we did now for convenience, we ported Podman space compose for compatibility. And if you have Docker installed, our API will forward to the Docker API, like the instructions to make it happen. So the way Docker will do it, and so that if there are no problems in the communication, it will be their problem, not ours. And as long as there are compatible images, and so as long as you don't do like swarm inside of the compose. I don't know if it's possible, but until you do something that Podman doesn't support, the result will be OCI compatible most of the time, so then you can then do whatever. If you don't have that installed, I think that we are compatible as well, and we will use our compatibility layer API, and well, it will mostly run. I just show it with Docker because I have it installed for debugging purposes. Other questions? Yes? It is web UI. You have to install. Cockpit is just web UI. Yes, you have to install Cockpit and Cockpit-Podman, and it will work. Question there.
Is there a way to convert or generate the Quadlets out of the Docker Compose or whatever?
So Quadlets, is there a way to generate them out of Compose? I don't think so. There was another community package that was called, I think, Podlet, that was generating Quadlets. I don't know much about it. What I do is that I generate them with Ansible because it has a simple syntax that is similar to Compose, and it will populate my Quadlet files with all the correct instructions. For example, all the time when I write a Quadlet, I do port equal. No, it's published ports. So, and then it will fail. If I delegate it to Ansible, it's just ports, and I can put there a list. It's a bit simpler for the same syntax, and it's easy to port. But we don't have a generator for that, I believe. Podman Desktop has some support for that, Dan said. So, yes. Question there? Are health checks going to be supported by OCI images as well in the future? I don't know, to be honest. So I can't answer that. If you mean putting something into the build so that it goes to the manifest of the OCI, possibly, but honestly I don't know this answer. Maybe there is an issue already open somewhere upstream. I should check it out. Is it possible to run pods into Quadlets and run them with systemd? Sure. You just have to define something like mypod.pod, and then inside you have square brackets pod, and then in a container Quadlet file, you will have pod equals name of the file.pod. So it will have the dependency. Not sure if I have it in the Quadlet example here, but it might be there. So check the presentation, go to the to the demo that's recorded here. And I don't remember if I did, but if I didn't, it's just one more file. Yep. And we're out of time. Thank you.